All right, so I wanted to do some examples just from the homework over types of reactions in balancing, just to kind of give you a little more help. So let's start with number one. Okay, so what we're doing is we're telling what type of reaction it is, and then we're going to go ahead and balance it and tell our order of coefficients. So let's just take a look and see what's going on. I have N2 plus O2, and that gives me one product here. Okay, so anytime you're taking two things and you're making one product, this is going to be a synthesis reaction. Okay, so making two things into one, that's going to be called synthesis. Now let's worry about our balancing part. Okay, so I'm going to look at the elements I need to balance. So I have nitrogen and I have oxygen. Okay, again, remember I always save oxygen for last. Now we're going to count how many I have on the left side versus how many I have on the right side. So I've got two nitrogens on the left. I've got two nitrogens on the right. Okay, I've got two oxygens on the left and only one oxygen on the right. Okay, so nitrogens are good, so let's move on to oxygens. So what I would need to do is I would need to put a 2 in front of this N2O. Okay, that would fix my oxygens to 2, but now that actually multiplied my nitrogens to a 4. Okay, so now I have 4 nitrogens on my right side. So I need to go back and fix my nitrogens now. So if I have 2 nitrogens on the left, but I need 4, I'm going to put a 2 in front of here. And now I have 4. So my numbers all match, so everything is balanced out. Okay, so my order coefficients would be, so here's a 2. Again, if there's nothing here next to the O2, that's like an imaginary 1. So my order of coefficients would be 2, 1, 2. Okay, and let me change the size of my pen ink real quick. Okay, let's try another one, and I'll do a different color just in case it starts to blur a little bit. Okay, so I have S8 plus O2 gives me SO3. Okay, so I have two things turning into one thing. So again, this is another synthesis. Okay, so let's worry about our balancing. So I have sulfur and I have oxygen to balance. I've got 8 sulfurs on the left. I've got 2 oxygens on the left. I've got 1 sulfur on the right and 3 oxygens on the right. Okay, so we're going to worry about those sulfurs. Okay, so I've got 8 on the left, so I need 8 on the right. So I'm going to put an 8 in front of this SO3. So this changes my S's to 8. But it also changes my oxygens to 24 now. So 8 times 3 gives me 24. So I need to fix my oxygens. So I have 2 on the left, so I need to get to 24. So I'm going to put a 12 in front of this. Now this fixes this to 24, and now my numbers match. So this is all done. So my order of coefficients, now if there's nothing in front of the S8, that's like an imaginary 1. So my order of coefficients would be 1, 12, and then 8. Okay, let's look at the next problem. I have C6H12O6 plus O2 gives me CO2 and H2O. Now, anytime you have anything reacting with oxygen and it gives you CO2 and H2O, it will be combustion. And I'll go ahead and do a different color ink for this one. So this will be combustion. Okay, combustion always looks the same. It's always O2 gives me CO2 and H2O. The only thing that ever changes is this hydrocarbon right here. That's the only thing that will change. Okay, so now let's actually worry about our balancing part. Okay, so I'm going to root this over here so I can give myself a little more room. So I'm going to do C, H, and O. Okay, again, I always do it the same way. I always start with carbons, work my way to hydrogens, and I always save oxygen for last. So I've got 6 carbons on the left. I've got 12 hydrogens on the left. And I have 8 oxygens on the left. So 6 plus 2 gives me 8. Now on the right, I have 1 carbon, 2 hydrogens, and 3 oxygens. Okay, so let's start with carbons. I've got 1 on the right, and I need 6. So I'm going to put a 6 in front of this CO2. So that fixes my carbons to 6. But now 6 times 2 gives me 12. Plus this 1 oxygen right here, so now I have 13 oxygens. Okay, so let's go ahead and move on to hydrogen. We'll worry about oxygen here in a second. Okay, let me clear that up. So hydrogens, I have 2 on the right, but I need 12, so I'm going to put a 6 in front of here. So 6 times 2 gives me 12. Now let's recount our oxygens. So I have 6 times 2 gives me 12 on the CO2. So 6 times 2 gives me 12. And then now I have 6 here. So 12 plus 6 gives me 18. Okay, now what I'm going to do is I need to get to 18 on the left, Okay, so this is what I was talking about in my other video, is the last thing I want to do is touch that. Okay, because if you do, that's going to restart you all over. So I'm going to leave that 6 oxygens alone. I'm basically going to say 6 plus what would give me 18? Well, that would be 12. So what could I multiply this 2 by to get to 12? That would be a 6. And now I would have 18 oxygens. So now this would actually be complete. Okay, so I did nothing in front of the C6H12O6. That's an imaginary 1. And then I would do 6 in front of the O2 and 6 in front of the CO2 and 6 in front of the H2O. So there's your coefficients right there. Okay, let's look at the next problem. Let's switch colors. We'll go orange. Okay, so I have a single sodium and H2O. Okay, but it looks like H was boosted out, and now sodium is with a hydroxide ion. So what happened is this is called a single replacement. Okay, so single replacements when you have one atom basically takes the place of another and boots the other one out. Okay, so now let's worry about balancing. So all I have, so now this is my trick that I like to do, is when you have OH, when you have hydroxide like this, I look at that as a polyatomic ion. Okay, so when I do this, I change my water into HOH. Now I can try both ways to see if both ways is just as easy. Okay, so let's try it without doing the HOH trick. We'll see if that works. Okay, because I know sometimes that can get a little bit confusing as you kind of run into a dead end, but we'll find out what we can do. Okay, so I've got Na, and I've got H, and then I've got O. Okay, so on the left I have 1 Na, 2 H's, and 1 O. Oops. On the right I got 1 Na, I got 3 H's, and I got 1 O. Okay, so I've got basically my NAs and O's are good, so I just need to get my hydrogens. But the only problem is I've got hydrogens in 2 places. Okay, so if I need to get to a number between that can be divided by both 2 and 3, I would assume that would be 6. So I would multiply this by 3. Okay, so that gives my hydrogens to 6. But now my oxygens are at 3. Now my hydrogens, this is where you can kind of run into a little trick, because this H right here, you have an H here, and you have 2 H's there. Okay, so now it becomes the hard part. So what I can do is I can multiply this by a 4. Okay, to make my H's out to 6. Okay, now my sodium's at 4. Now let's look at my oxygens. Now my oxygens are at 4, but then if you look, that just starts us back over again. Okay, so this is where that kind of trick comes into play. So let's kind of clear this out. So now what we're going to do is we're going to switch it into the HOH. So that was just to show you the troubles that you can kind of run into and stuff with that. So this little HOH trick, so what I would do is I would cross this out, and I would just say this is the same as saying HOH. So now the things I had to balance are sodium, hydrogen, and hydroxide. So I have 1 sodium on the left. I have 1 hydrogen on the left. Now, this is the hydrogen I'm talking about. This hydrogen right here is attached to that OH, so we do not care about that. So we do not have 2 hydrogens. That's technically 1 hydrogen and then 1 hydroxide. Okay, now on the right, I've got 1 Na, I've got 1 OH, and I've got 2 H's. So let's look. So I need to get my H's to 2, so I'm going to put a 2 in front of this HOH. Okay, that fixes my H's to 2, but now I have OH's. Now my OH's are 2 on the left. On the right side, I need 2 OH's, so I'm going to put a 2 in front of this NaOH. So that fixes my OH, but now my NAs are at 2. So all I got to do on the left side is I need to put a 2 in front of that so I can fix my left side Na to 2. Now all my answers are good. So basically my ratio would be 2, 1, 2, 1. Okay, now let's look at the next one. So I've got HGO breaks down into Hg and O2. So anytime you take one reactant and break it down into multiple products, that is called decomposition. Okay, and I'll go ahead and switch inks again. So decomposition. So let's look at what we had to balance. So I've got HG and O. Not much going on there. I've got one HG on the left. I've got one oxygen on the left, one HG on the right, and then two oxygens on the right. So I need to get two oxygens on the left, so I'm going to put a 2 in front of here. So that'll fix my oxygen to 2. But now my HGs are 2 as well. So now I need to fix my HGs on the right. So all I need is 2, so I'm going to put a 2 right here. And now my HGs are 2 on the right, so my numbers are all done. Okay, so my ratio would be 2, 2, 1. Okay, so let's skip a little bit. Okay, I want to make sure I get to all the types of reactions. So we're going to go here to number 7. I have AlOH3 and H2SO4, give me H2O, and Al2SO4, 3. So if you notice, I have a pair here and a pair here. And then basically what happens is they switch partners, and I still have a pair here and I have a pair here. Okay, that is called double replacement. So anytime you have two pairs and they swap partners, that is called double replacement. Okay, so now let's worry about our balancing. So this is where those polyatomics come into play. Okay, so if they are polyatomics on both sides, you want to keep them as polyatomics. Okay, so if I've got OH on the left side and I've got H2O on the right side, I'm probably going to go ahead and switch this to HOH just to save myself a little hassle there. Okay, and then I have SO4 on the left and SO4 on the right, so I'm going to keep those as SO4. So realistically, I have aluminum to balance, I have OHs to balance, I have hydrogens to balance, and I have SO4s to balance. Okay, so let's see how many we have. I have 1 aluminum on the left. I've got 3 hydroxides on the left. I've got 2 hydrogens and then 1 sulfate. So again, this right here is just 1 sulfate. Now on the right side, I have 1 H. I've got 1 OH. I've got 2 aluminums. And then I've got 3 sulfates. Okay, so let's just start our way at the top. So if I have 2 aluminums on the right, I need 2 aluminums on the left, so I'm going to put a 2 in front of this. Okay, so that fixes my aluminums on the left side of 2. Now 2 times 3 gives me 6 OHs. Okay, so make sure you're updating your numbers as you go. Don't put a 2 in front of aluminum and forget to update hydroxide. Okay, so let's move on to hydroxide. I have 6 on the left and only 1 on the right, so I'm going to put a 6 in front of this HOH. Okay, so that fixes my hydroxides to 6. But now my hydrogens are at 6 as well. Okay, so now let's move on to our hydrogens. I have 2 on the left, 6 on the right. So what I'm going to do is I'm going to put a 3 in front of this H2SO4, and that will fix my hydrogens to 6. And also in one sweep, 2 birds, 1 stone, it fixes my sulfates to 3 as well. So now all my numbers match. Okay, so now I'm done. So I'm going to write my ratio would be 2, 3, be a 6, and then there was nothing in front of the Al2SO4. Okay, so that was basically just a 1. So there's your answer there. Okay, now I want to do number 8 because this may have already been in my other video, but I want to talk about is what happens when you run into a decimal. Okay, so first I'm going to look at this problem. So I have something reacting with oxygen, and I get CO2 and H2O. So that would be a combustion problem. So let me switch my ink colors real quick. So this would be combustion. Okay, so let's look at balancing it. So I've got carbon, hydrogen, and oxygen. Okay, I do that the same way every single time. So I've got 7 carbons on the left, I've got 6 hydrogens on the left, and I've got 4 oxygens on the left. On the right side, I have 1 carbon, I've got 2 hydrogens, and 3 oxygens. Okay, so let's just start with our carbons. Okay, so I'm going to go ahead and draw little lines in front of here, so that's where I can write my numbers. Now, one thing I want to point on this, just like I've kind of talked about in my other videos too, is the last thing I want to do is touch that one. Because if you do, all of a sudden you are shifting everything and you're basically starting over. So again, save that one only if you need to. So I have 7 carbons on the left and only 1 on the right. So I'm going to put a 7 in front of that CO2. So that switches this. Now it fixes my carbons, but now you have to pay attention to your oxygens. 7 times 2 gives me 14, but don't forget this 1 right here. So that's actually 15 oxygens. Okay, now let's move on to hydrogens. I have 6 on the left, only 2 on the right, so I'm going to put a 3 in front of that H2O. Okay, so that becomes a 6, but we can't forget to update our oxygens. So 7 times 2 gives me 14, plus 3 times 1 gives me 17. So now I have 17. Okay, so that's a pretty uneven number. Okay, so now I got to fix my oxygens on the left. So again, last thing I want to do is touch that. So I'm going to leave that 2 the way it is. I'm going to leave those 2 oxygens there. So 2 plus what would give me 17? That would be 15. So that means whatever I have over here needs to be a total of 15. So if you took 15 divided by 2, I would need to multiply this by 7.5. Okay, and let me clear this out real quick. So go ahead and write the decimal down. If you get stuck into that part, go ahead and write the decimal down. It's always going to be in 0.5s. Okay, so just go ahead and write it down, and then we'll fix it. Okay, so I cannot have a decimal. So what I can do, this is called, whenever you get a decimal like a 0.5, it's called basically just double it all trick. Okay, so what I'm going to do is I'm going to double this 7.5 to fix that decimal. So this 7.5 becomes a 15. But it's unfair to do that to 1 and not do it to them all. Okay, so if we double 1, we have to double them all. So this 1, imaginary 1 that was in front of this C7H6O2, now becomes a 2. This 7 becomes a 14. And this 3 now becomes a 6. Okay, so let's make sure we're good. So 2 times 7 gives me 14 carbons on the left. Okay, on the left, I'm still working on the left, so 2 times 6 gives me 12 hydrogens. And then let's count all of our oxygens. 2 times 2 is 4, plus 15 times 2 is 30, so this would actually be a 34 now. Okay, so on the right side, let's check. So 14 times 1 carbon gives me 14, so that one's good. Now let's look at our oxygens. 14 times 2 is 28, and then 6 times 1 is 6, so 28 plus 6 gives me 34, so that one's good. And now let's look at our hydrogens. 6 times 2 gives me 12, so I have 12. So all my numbers match, so that means this one is done. Okay, so again, that's how you do the decimal trick. So my ratio would be 2, 15, 14, and 6. Okay, so that was basically how you do the balancing and the types of reactions. We went over combustion, we went over a double replacement, we went over a single replacement, we went over decomposition and synthesis. So please let us know if you need anything else or need any help.